Hey everybody, we're going to give it just another minute for people to continue to come in, and then we will get started. Thanks so much for joining us today. Right, it's 1 o'clock. A few seconds. See, we have about 50 people here. Fantastic. Thanks so much for attending. All right, well, thank you again for attending today. Welcome you. Describe paper, we just energy. Okay. Is that any better? Shoot.
Yes, something blocked the camera and mic for a moment, but you're back.
Oh, okay. That was very odd. All right, sorry, I will start again. There's always technical difficulties that we did not have before. Okay, and I can click my slides. Thank you. All right, so most of you know who we are. Thank you for attending, but if you don't know who we are, the DLC is a nonprofit organization. We provide decision makers with data and resources on quality lighting, controls, and integrated building systems to reduce energy consumption, carbon emissions, and light pollution. We collaborate with many stakeholders, including utilities, energy efficiency programs, manufacturers, lighting practitioners, building owners. Is it still blocked?
Nope, you are clear. Yeah, everything's good.
Oh, perfect. I'm just seeing late text. Sorry, everyone. We're trying to communicate by text. Okay, perfect. Building owners and government entities to create rigorous lighting performance requirements that keep pace with technology. Light pollution is bad and it's getting worse. Outdoor lighting proliferation has resulted in an unintended consequence of light pollution. Pursuing high-performance lighting and lower costs is important, but it should be done with an eye towards mitigating the negative consequences of wasteful lighting practices. Pursuing both energy efficiency and light pollution mitigation will yield additive benefits in terms of energy savings, carbon reduction, as well as non-energy benefits for the environment and for equity. If we look at satellite data, we see a year-over-year increase in light pollution of at least 2% for the past 25 years. But our satellites don't capture the light below 500 nanometers, so the increase in blue light from white phosphor-converted LEDs is not measured. Satellites also measure light near zenith, so these measurements are underestimates. Last year, research showed that light pollution is growing much faster than we previously thought, at a rate of about 10% year over year, based on star appearance from the Earth. As we're focusing on light pollution today, let's keep in mind the heroic effort it's going to take all of us to address climate change and to turn around our global temperature rise. Light fixtures that are specified to minimize light pollution also need to be energy efficient and support demand flexibility. We should prioritize designing lighting installations that minimize light pollution and support larger decarbonization goals. Energy efficiency and controllability will become even more important as we make progress to electrify our built environment. Many end users, including contractors and energy service companies or ESCOs, continue to chase energy efficiency improvements without considering the impacts of light pollution. Every new outdoor LED installation that doesn't mitigate light pollution and isn't controllable is a decade-long, even generational-long mitigation loss, because these products simply last so long. Choosing responsible solutions now, each and every time, is imperative to decrease light pollution. Local governments are also looking for guidance. Many have decarbonization goals and dark sky ordinances, but they can be understaffed and may not have the expertise to know how to spot problematic installations or products. They are looking not only for actionable guidance, but for straightforward solutions. Luna is the DLC solution to outdoor lighting that is both energy efficient and minimizes light pollution. Luna is built on top of our SSL 5.1 performance requirements, which include minimum thresholds for outdoor fixture efficacy, color rendition, color maintenance, LED life, warranty, and safety. We conduct rigorous third-party evaluations of each submitted product or product family. And on top of being energy efficient, Luna fixtures must also have minimal or no uplight and can't point the light distribution directly up to the sky. Color temperature is limited to a maximum of 3000 K because blue-violet wavelengths are more detrimental to sky glow and to non-human species. Finally, all Luna fixtures must be dimmable to at least 20% of full power to limit overlighting and to support the use of light only when and where it's needed. The simulation study I'm going to review today was completed in collaboration with BH Lighting Services and Lighting Research Solutions to analyze the performance differences between LED fixtures that meet the Luna technical requirements compared with DLC qualified products that don't meet these technical requirements. The study answers the following question. What are the impacts on annual energy use, energy costs, and ROI if a city or town decides to use a retrofit solution that is both energy efficient and mitigates light pollution, rather than focusing on energy efficiency alone? Now, we selected Fort Collins, Colorado as our site for a variety of reasons. First, it has an average US high school in terms of population, it has a progressive lighting ordinance, and a modern energy code. Fort Collins is also served by one of DLC's program members and has realistic application scenarios that can be used for digital twin studies. The simulations that we conducted were comprehensive and included photometrically accurate lighting calculations, additional spectral sky glow calculations, and economical analysis. Now, while Luna provides a list of products that can meet outdoor lighting ordinance requirements and mitigate light pollution, it's really important in application that we choose the right size products, that is, the products with the right amount of light and the right distribution, because minimizing overlighting is critically important to minimizing our light pollution problems that we have today. In addition, we also want to look at the effects of dimming both on light pollution and on reduced energy use to make sure that we completely value and use the controls products that are available and control solutions that are available today. Now, the two outdoor applications that we chose within Fort Collins, Colorado, included the exterior grounds of a model high school, including the parking lots, and a main street in downtown Fort Collins. The lighting design that we used for the model high school had three scenarios. First, we had a base case, and the base case was based on existing fixture locations and heights for pole-mounted fixtures and wall pack fixtures. A linear set of bollard fixtures was added to illuminate an additional walkway. And in this particular base case and in the street lighting base case, we used high-intensity discharge fixtures for a few reasons. In this case, for the high school, we made an assumption that metal halide fixtures would have been used at the time, and we chose appropriate wattages to meet the best practice illumination criteria that was published in the early 2010s. College Avenue, our downtown application example, had several different types of fixtures installed, including roadway fixtures, very tall area lighting fixtures, and pedestrian scale fixtures that were scattered throughout various blocks. As a result, we simplified the scenarios into three application examples. We looked at one example with roadway style fixtures, another example with area lighting fixtures, and a third with decorative pedestrian scale fixtures. Now, the fixture selection for the base case here at College Avenue was based on the 2007 Larimer County standards, which required 400-watt HPS roadway fixtures and 1,000-watt metal halide area lighting fixtures at very tall mounting heights. The Larimer County street lighting standards also had illuminance requirements, which we used as well. For the decorative pedestrian scale application, We chose metal halide fixtures in our base case to meet those illuminance requirements that were present at the time. Now, in each case, so we have 4 application scenarios, 1 for the model high school and 3 streetlight scenarios in College Avenue. We had 3 scenarios in each one. The base case, as I mentioned, which was HID with no dimming. A retrofit scenario 1, which represents sort of typical incumbent retrofits that are conducted today. These include DLC listed 5.1 luminaires with a CCT of 4000 K, and we applied 50% dimming as required by the energy code that is used in Fort Collins. In our second retrofit scenario, we also use DLC qualified luminaires, either those that are already Luna listed or those that are eligible for Luna qualification with CCTs of 3000 K. For this scenario, we also designed the layouts to meet the Fort Collins outdoor lighting ordinance requirement, which is very comprehensive. And in order to do this, we minimized overlighting and chose lower wattage products when possible, and enabled deeper dimming after the curfew down to 80% of full power to further reduce energy use and light pollution. So why did we pick HID for the base case? Well, of course we know that much of the outdoor lighting that is installed today, the vast majority is already LED, but we also know from recent research that light pollution has accelerated at a faster rate since LEDs have replaced high pressure sodium predominantly, but also metal halide for outdoor lighting. And this study allows us to look at the differences in light pollution across all 3 cases in application for an apples to apples comparison. So just to review, these are the energy code requirements that were present at the time and are present now that are used to guide the maximum wattage of products that are installed in these simulation scenarios. ASHRAE 90.1 2007 was the energy code used in Fort Collins at the time of our base case, with an overall lighting power density allowance of 0.4 watts per square feet for lighting zone 2. And for the retrofit scenarios in 2023, 2024, ASHRAE 90.1 2019 was selected, as this is the energy code used by the city of Fort Collins. And lighting zone 2 criteria was also used. Now let's look at the pre-curfew outdoor lighting requirements and best practices used in the study. These criteria were used to select the right light output and distributions for both the base case products and the LED lighting fixtures, given a 1-for-1 replacement requirement in this retrofit study. In other words, we did not add or change pole locations or add or change wall-mounted fixture locations. We simply picked products that met this lighting criteria, allowing again for apples to apples comparisons. And before we dig into the Fort Collins outdoor lighting ordinance, I wanted to highlight a tool that we created to facilitate you finding your local laws and requirements regarding outdoor lighting. This tool is an interactive outdoor lighting ordinance map for the United States and Canada. This is a free resource for you to use, but of course we can't help you interpret or enforce the local ordinances that you see here. Ordinance language can be confusing to lay people and lighting professionals alike, and meeting the requirements as well as recommended lighting levels may be a challenge. So I'd like to initiate a quick poll here to find out if you have a local lighting ordinance in your community. And Andrew, I will let you drive the poll.
It is launched and people are answering now.
Terrific. Give it a minute or so, and then if you could share the results. I cannot see the poll on my screen.
Sure. We have about 75% people voted, so just wait for it to shore up. It's filling up quickly.
Great.
Looks like we're yes. Kind of stalling at 80%, but it's looking like over half of the people in the room do have a lighting ordinance, outdoor lighting ordinance. 14% say no, and 36% say not sure.
Okay, thank you very much. So for those of you that aren't sure, I hope you can use this map to see if you have a local lighting ordinance in your community. Fort Collins local lighting ordinance is actually included here, as well as about 450 other ordinances across the United States and Canada. We are regularly updating this resource. So if you don't see your local ordinance here and you know you have one, please email me and we will look into adding it to this map. Thank you. Thanks for running that, Andrew. All right, so let's look at Fort Collins outdoor lighting ordinance. Whoa, is it not sharing my screen?
We see it. I just closed the poll, so I think it just probably
I'm
glitched.
just seeing myself on top of the screen. Okay, perfect. Thank you. That was startling. Sorry, everyone. All right, so Fort Collins has an especially comprehensive lighting ordinance with some fairly rigorous criteria, and the link for the ordinance is shown here below. So overall, for street and area lighting fixtures, the CCT of those luminaires installed cannot exceed 3,000 K. They use lighting context areas instead of lighting zones. They're similar to lighting zones, and Fort Collins actually provides a map with the overlaid lighting context areas across its municipality, which is fantastic. Much of Fort Collins, including all the high schools in Fort Collins, are in lighting context area 1, which is very similar to lighting zone 2 that you would see in the energy code. Fort Collins sets bug rating thresholds and uplight thresholds by lighting context area. And for lighting context area 1, there is a 0% uplight requirement for area and street lighting. All other outdoor luminaires have to have a U0 requirement. It also has a G rating requirement from the bug rating system, and they require a G rating of G1 or lower for all outdoor luminaires in this lighting context area. There are also lighting trespass requirements in Fort Collins per lighting context area. In lighting context area 1, there is a maximum horizontal illuminance requirement of 0.1 foot candles. And Fort Collins also limits overlighting by limiting the total initial lumens per site depending on the lighting context area. So very comprehensive indeed. Now let's look at the simulation tools that we use to analyze product performance. In this case, we use 3 different sets of simulation tools to inform the results. First and foremost, we use photometric software to look at the lighting performance of the selected products against the local ordinances and standards and the IES recommended practices. We use the AGI 32 illumination engineering software programs to do these photometric calculations. This is a tool that is used widely across the United States and Canada, and it allows for photometrically accurate lighting calculations that look at both the direct light and the light that reflects between surfaces. The software also has a tool that calculates the light pollution performance using the model lighting ordinance performance method that has been put forward in the past by the IES and Dark Sky International. So we use that as well. Lighting software is not comprehensive enough. In fact, it does not consider atmospheric scattering effects. So to calculate the impacts of the different CCTs we selected on sky glow, we needed to use another tool. As part of our application process, the DLC receives measured spectral data files from manufacturers for review. The spectral data is reported in a standardized data format using XML called an SPDX file, and that standard comes from the IES. As DLC qualified products were used throughout the study, the research team used the submitted SPDX files for further analysis. Of course, this data is anonymized. We used an Excel tool to look at this analysis from the DOE developed by PNNL that calculates the relative sky glow due to spectrum compared to a reference source. For this study, we only evaluated the differences in sky glow due to spectrum using HPS as the reference. You can choose another reference if you'd like. The tool also allows for looking at differences in uplight or different light outputs. We did not avail ourselves of those calculations in this particular study. Now, to calculate ROI and payback, we also built a cost calculator that allows for easy comparisons between the scenarios, including dimming set points, incentive dollars, and a sensitivity analysis for different electric rates. We decided to share this spreadsheet broadly with our stakeholders, and you will find a link to this free cost calculator in the white paper, and we'll be sharing it at the end of the presentation. Let's look at the results. and the potential optimization of energy efficiency and light pollution mitigation. Let's begin by looking at the results of the model high school. As a reminder, the retrofit scenario 1 looks at DLC qualified outdoor fixtures with a CCT of 4,000 K, and RS2 looks at LUNA qualified or LUNA eligible fixtures and minimizing overlighting as a focus. In practice, this means that selecting slightly lower wattage products when possible to save energy while still meeting the lighting design criteria that I mentioned earlier. So let's look at the results of RS1 or retrofit scenario 1. Using controlled energy efficient DLC qualified lighting reduced the site power demand by almost 50% compared to metal halide. This is not a surprise, right? This is what we expect to see with LED retrofits forever. If we look at the LUNA qualified eligible fixtures, savings above and beyond the standard 4,000 K solution is there. We actually save 20% more power demand by using LUNA qualified fixtures and minimizing overlighting in this scenario. Now, if we look at College Avenue, we see similar results. Let's begin by looking at the roadway fixtures. Power demand between RS2 and RS1 decreased by an additional 11%. Again, we see big energy savings from the base case, in this case, HPS to LED. No surprise there. With the area lighting installation, we see slightly different results. Now, in this case, in Fort Collins, the area lighting product had a very high mounting height, over 50 feet. And in this specific application, the 3,000 K LUNA eligible fixtures that were selected in RS2 were slightly less energy efficient than the 4,000 K fixtures selected in RS1. So we see a slight increase in power demand in this particular scenario. If we look at the decorative scenario, we also see the same types of results we saw with roadway. We see big energy savings switching from metal halide, in this case, to LED. But again, incremental energy savings with LUNA eligible products and minimizing overlighting on the order of about 10% in this particular application. So in summary, LUNA products and thinking about light pollution mitigation in application does save incremental energy and gets us halfway there in our goals. So what about light pollution mitigation? So here, results that you're going to look at provide objective information with regards to light pollution performance, in this case, looking at the pre-curfew mode, so sort of the worst case mode. These comparisons include the photometric performances using the tools that we have in AGI 32, as well as the spectral performance that we gain from using the PNNL SkyGlow simulator in terms of relative performance. So again, because the spectral atmospheric calculations are relative, we're going to set the base cases here to 100%. So let's look at the high school. Here we have metal halide as a base case. Given our design criteria from back in the day, we see a relative light pollution performance of 100%. And if we switch to 4,000 K LED, we see an increase in light pollution performance. Small increases, about the same, maybe slightly worse. What if we look at the RS2 with the LUNA solution and minimizing overlighting? We see a very large reduction in light pollution performance, given all of the factors that impact light pollution. Here we see light pollution reductions on the order of 43% by using all the tools at hand in our toolbox. Now let's look at College Avenue. In this case, let's begin with our base case with the roadway lighting. Here the base case was HPS. When we set HPS as the baseline at 100%, we see almost double the light pollution performance when we look at 4,000 K, 87% higher than the base case. When we compare apples to apples comparisons in terms of photometric performance, when we look at 3,000 K, we still see an increase over HPS. This is a really important finding. 3,000 K will not reduce light pollution relative to HPS, even if everything is equal, okay, because we have slightly more blue light with 3,000 K. Now, when we look at the area lighting performance, in this case, metal halide is the base case. So 4,000 K is pretty similar to metal halide. we see a slight reduction in light pollution performance. 3000K has less spectral scatter than the metal halide, so we see a reduction of about 20% in light pollution performance. The most interesting results come from the decorative pedestrian scale scenario. So in this case, metal halide is the baseline again, as we mentioned, but simply switching to LED led to a big reduction in uplight. And that reduction in uplight alone led to a reduction in light pollution performance of 40%, even though the 4000K spectrally is quite similar to the metal halide. When we decrease the CCT to 3000K and use all of the solutions given to us in our Luna toolbox and minimizing overlighting, we see further reductions of light pollution performance down to 30% compared to the base case. There's a lot of opportunity here to save energy, save money, and reduce light pollution by using the right products at the right time. Let's look at the cost. This is a peek into the economic analysis that we conducted in the white paper. This uses a 12-cent per hour kilowatt hour rate. All of the details behind this analysis are actually in the cost calculator, and obviously you can use that to create your own scenarios. But I want to focus here on two aspects of the analysis that I think are important. First, let's look at the energy costs. In the model high school, energy costs were reduced by about 40% due to both the power demand reductions that I mentioned earlier, but also due to deeper dimming in RS2. In general, these trends also hold true for the College Avenue scenarios that I mentioned as well, although the energy savings percentages are smaller here than in the high school. In the case of the area lighting scenario that I showed earlier, the energy costs increased slightly by about 3% due to deeper dimming, even though these products were less energy efficient than the 4000K products that were selected. I also want to point out at the bottom here the relative cost of the network lighting controls that were used to dim the lighting in these scenarios. The NLCs used here made up about 15 to 50% of the total material costs because these applications were small, especially the street lighting applications were small. Now let's look at the payback periods for the RS1 retrofits compared to the RS2 retrofits, including incentives for both the LED lighting and for the network lighting controls. As the electrical rate increases, we see a decrease in the payback periods, right? That's not surprising. We would expect that from any ROI. In general, we found that the payback periods for RS1 and RS2 were pretty similar. This is really good news because the LED fixture costs in totality were about the same for Luna and non-Luna products. And the NLC system cost was obviously the same. We did find that the roadway and decorative fixtures had the longest payback periods, whether we were looking at RS1 or RS2. So that's the longer timeframes that you see there. And as I mentioned previously, the NLC costs made up a significant portion of the material costs and increased the payback periods by a commensurate amount. Now, I want to show you how we use some of the new tools that I mentioned before that aren't commonly used in photometric analyses. And I want to review the outcomes of one of the tools in more detail with you today. So, one of the most effective ways that we can understand the impact of lighting application on light pollution performance is to understand the atmospheric scattering effects of light. Our photometric tools, as I mentioned before, do not have an atmosphere in them. It's basically a vacuum. So we have to move beyond photometric calculations to see the comprehensive impact. So to begin with, we should continue to do photometric calculations as we have always done to select products and to understand product performance with regards to standard illuminance calculations. To understand the spectral performance, we will need to use SPD data from the manufacturer. One of the benefits of the Luna QPL is that we publish the SPDX data directly for the worst performing products on the list amongst a family. Now, once we have the SPD data, we can enter it into the PNNL calculator and get the relative sky glow value or RSG value here. More detail about this is shown in the Lucos paper that Tony Esposito and I published early last year. And Tony is here on the call with us today. Thanks, Tony, for joining. And if you have any detailed questions, we might be able to get him to answer them. I'll provide a link to this paper at the end. And finally, that RSG value is applied to the photometric calculations, either as a scaling value to your luminaires, like a factor, or to your grid values. So this slide, I'm showing you the average RSG values for a subset of different white CCT LED products for your reference. Now, this is a pretty small subset, about 175 products, but it's quite informative, I think, even though it's small. I'll explain to you how I got these values in the next slide. So what do these averages mean that I'm showing you here? Well, if you look at the table, you'll see that a 4000K LED product on average has an RSG value of 2.8, whereas an HPS product, in this case defined as our baseline, has an RSG value of 1.0. That means that a 4000K LED product, all else being equal, that's really important, all else being equal, will have a relative sky glow increase that is 280% higher, or 2.8 times higher than HPS. And if you look at the trends in the table, you will see that the numbers increase. So as CCT increases on average, RSG also increases. Now, looking to the future, if we really want to reduce light pollution to levels as we had when we were using HPS as the dominant technology in outdoor installations and still gain all the benefits of LED, dimmability, controllability, all of the granularity that we get with LED, we will have to look at installing more 2000K, 2200K products and minimizing uplight, overlighting, and increasing installations and control products. That's the way we're going to get back to where we were before, and we can do that because of innovations in LEDs. Now, in practice, it may be easier to get SP ratios from manufacturers than it is to get SPD data. We found in our Lucos paper, we'll share later, that SP ratio was the best predictor of relative sky glow amongst a wide variety of metrics. And so if you are able to get the SP ratio from a manufacturer, you can simply use the equation at the bottom of the screen to get the relationship between SP ratio and relative sky glow. And that way you can look at those relative impacts of light pollution when all else is equal. So where do the numbers I showed you on the previous graph come from? Well, in our previous research from 2022, we were able to obtain 175 SPDX files across various CCTs to calculate RSG. These 175 SPDX files represent measured data from manufacturers received during the DLC application process. The data, of course, is anonymized. And I want to show you the variance in between the products, not just the averages. So as I'm scrolling through the chart, you can see that as CCT increases, RSG on the y-axis increases, right? We see a monotonic relationship here. And some products, especially those where we have quite a large subset of products, say at 5000K, we see a wide variety between products. But the averages that I showed you in the previous slide are shown with the X's on this slide. And even though there's a larger variance between products, you can still see that relationship where as CCT increases, RSG increases. Now, I said earlier that SP ratio is the best predictive metric for predicting RSG. So you will see much less variance in these box plots here. The boxes are smaller, and that's because SP ratio is a good predictor for this particular metric. And again, you can see this monotonic relationship. As CCT increases, SP ratio increases, and therefore RSG increases. Now, the other tool that we are showing in this paper and making available freely is our cost calculation tool. This is a tool that the research team developed to support the white paper. This is freely available for you. We're going to link it at the end of the presentation. It's also in the white paper. I hope that you find it useful and helpful. If you have any feedback, please feel free to share it with us. Now, as we look at the larger, broader study, I wanted to share some of the lessons that we learned specific to this application, specific to the products that we selected. These are not necessarily generalities in all cases, but I wanted to share them with you today. First of all, one of the things that we found here was that there was a conflict between the local ordinance requirements and other performance requirements. So in this particular application, for the products that we looked at, we were not able to choose G0 or G1 products, that's the bug rating, part of the bug rating here, and still meet the recommended light levels from the IES or meet the requirements from Fort Collins. If we were to select G0 or G1 products, we would have ended up with much lower light levels in this case. So we ended up prioritizing meeting the light level requirements more than meeting the G requirement here. I am curious in the chat if you would have made the same choice. If you had a conflict between the ordinance requirements and meeting light level requirements, which way would you have gone? Would you have made a different choice than the research team chose in our white paper, in our simulation? Now, as I mentioned before, the Luna conforming products use less power and less energy than 5.1 products in most cases. We saw in the area lighting example that was not always the case. Again, we also saw that the Luna conforming products also minimize light pollution in all cases compared to the version 5.1 4000K products. I mentioned the cost of the selected NLC system. We found that the cost was not, that the systems were not cost effective for the very small applications that we studied in our white paper. The cost of an NLC is most attractive, most tenable when the cost is proportionally small to the overall total capital cost of the lighting system. So we think that one way to alleviate that cost barrier is potentially to have larger incentives for NLC systems. Those would bring down the payback costs, support reduced light pollution, support more dimming in practice. We did find that the Luna conforming products did have slightly longer payback periods than the RS1 or 5.1 products in about 2/3 of the scenarios, but the difference in payback wasn't that long. At worst, I think it was a year longer, but it was fairly small. You can see that in the cost calculator. We also found that some lighting control manufacturers were not interested in performing a control system for fixtures that they did not manufacture. So picking a control system from one manufacturer, luminaires from another manufacturer, was a bit of a challenge. There were possible compatibility issues. And this has a potential broader impact. If we cannot get these products to be compatible, if we do not enable dimming to happen more easily, this not only results in potentially longer payback periods and ROIs, but we may not be able to meet our larger light pollution mitigation goals and our energy efficiency goals if we cannot dim the lighting that we have. So I think this is something we all need to work on and make better. Controls are critically important in our future, as I mentioned before. So now that you've heard about the Fort Collins lighting ordinance, about some of the challenges that we had with this ordinance and some of the benefits of this ordinance, I'm curious about how you feel about your experiences and challenges with lighting ordinances in your community. So about, I think it was a little bit more than 50% of you have a lighting ordinance. So if you could answer the poll, let us know if you've had any challenges with your lighting ordinances, or if you are an expert. And if so, please call me and we can make it easier.
Results are coming in. Got about 10% people answering, so we'll just give them a...
Sure, this has a lot of choices here. And if you have an answer that is not one of our answers, feel free to put it in the chat, and we'd love to hear from you here.
People are steadily answering.
Thank you all. There's about quite a few of you here. Some of you I know. Very curious to hear what you think.
Half of the room is answered, so.
All right, let's go ahead and share the results so far.
Okay. To share the results, I do have to prevent people from answering any further. Do you want me to do that, or?
Yeah, let's go ahead and do that now.
Okay.
Just so we can save time for questions.
Sounds good. I'm gonna close the poll, everyone.
If you didn't have a chance to answer, please put it in the chat. Go ahead.
All right, so they're up on the screen. So it looks like, sure. So it looks like still most people say they don't know if they have an outdoor lighting ordinance.
Okay.
But if the people that do, we're about tied between my lighting ordinance creates conflicts with other requirements and my lighting ordinance is not enforced. And then we had 14% of the people say that their lighting ordinance is too vague or confusing. And 10% did say, there's no challenges. I'm an expert at finding compliant products. So we have some experts in the room.
All right, so those 10% of the people, put your information in the chat so we can talk later. I want to know your secrets. All right, thank you very much, Andrew. Okay, so before we get to questions, I wanted to share the resources that I mentioned earlier in the presentation. Now, Andrew is going to put these resources in the chat so that you have access to them immediately. You don't have to take pictures of the screen. You can have access to them now. We will also make the slides and presentation available after the fact. So in this case, that's where a QR code makes it really easy to find the resource that you want. So we have the white paper, the cost calculation tool. We have a resource we call 7 Strategies to Minimize Negative Impacts of Outdoor Light at Night. This is a resource we share a lot to say that it's not just about picking the right products, but it's actually about applying the products to have the biggest impact in reducing light pollution collectively. Our ordinances map link, the Lucas article that I mentioned earlier that Tony Esposito and I published, looking at metrics and a specification structure for non-white light sources. We didn't have time to talk about that today, but that is something that DLC is working very hard on. The SkyGlow simulator, if you'd like to see a little bit more about this tool and ask DOE for your own copy of the tool, the link is here. And that is all the resources for today. So before we get to Q&A, I just wanted to share one last slide with you. We are looking to host another Luna webinar in the near future, and the theme is going to be municipal solutions to minimizing light pollution. And in this case, we would like to invite stakeholders to share their experiences, both good and bad, in reducing light pollution. We're especially interested in having municipalities share their goals and their experiences. So if you are on this call and you would like to participate in a panel, participate in this webinar, please reach out to me. The invitation is both for experts and non-experts alike. Together, we can have the best of both worlds, right? We can increase energy efficiency to support our decarbonization goals, and we can provide high quality lighting for people and light pollution mitigation to benefit both people and other organisms alike. So thank you. We have about 15 minutes for me to answer questions, and Andrew is going to share those with me today.
Sure, we have a bunch of questions already in there. People have been filling it up.
Sure. If we don't get to all of them today, we will get back to you, I promise. You will hear from me directly.
Yes, that's right. We probably won't have time for every single one of them, especially the more technical ones. But one of the first questions that came in was, would amber lights solve the sky glow? That was from John Tutolomondo.
Oh, well, so the easy answer is, in many ways, amber is a good solution for reducing sky glow because it has less short wavelength content. So that spectral scattering is less. But there's downsides potentially to amber. A lot of amber products that are on the market, again, depending on the technology, may not be as energy efficient. And so you may have to use higher wattage products to meet the same photometric light levels. And it's not just about the color of the light source, or the spectrum in this case, it's also about the distribution of the light source. So even if you're using amber and you're pointing light up directly at the sky, or if you're overlighting, you still don't get that biggest optimization. So amber is a solution in our toolbox, and the DLC is actually spending a lot of time and effort to help people select amber more easily. So one of our efforts is in working with the ANSI committee that writes color standards called C78 standards. And we're looking at two aspects here. One is to update one of the standards we have to standardize what 2000K is and what 1800K is, because we actually don't have standards for those types of products today. And the other effort that we're involved in is to write a new standard that actually specifies nomenclature and color information for other types of amber products like PC amber, direct emission amber, even some sort of yellowish products that are out there, long wavelength products that are out there. So stay tuned for more information. Tony and I work together to work on those efforts, and we're hoping to help the industry overall and eventually to allow these types of amber products into Luna. We just need to get all the information and a standardized way of measuring these products. Great question.
We have another question.
You wanted a banana.
Someone was wondering, Scott Lind was wondering, what explains the dramatically lower RSG 40% and 70% from metal halide?
So those big differences there were for the decorative products. So the base case decorative products, in those cases that were metal halide, were not only metal halide lamps, but if you think about sort of the globe or the cover that covers those products also put out light in all directions, like a sphere of light, if you will, right? They didn't really have controlled lighting. So when we switched to LED, to 4000K LED, when we looked at qualified products, we already saw decorative products that had a lot less uplight. In those cases, even using 4000K reduced the RSG significantly, reduced the total light pollution value completely for the entire application because of the combination of uplight and the spectrum. When we go to 3000K, we get the benefits of spectrum, and we can also pick decorative products that have little, or in this case, no uplight at all, to further limit those effects of uplight. So spectrum and uplight both have sort of non-linear effects on sky glow. The light scatters in various directions. It interacts with different types of particulates in the atmosphere, and you see different types of scattering that occur. And so that is the difference there. Whereas in the case of the area lighting fixtures and the roadway lighting fixtures, 4000K and metal halide are pretty similar, maybe 10% plus or minus in difference. And the 3000K is where we start to see less short wavelength light, less blue violet light, and much lower RSG values overall. Great question.
Thank you, Leora. And someone else was wondering, what are the factors that are currently limiting the use of lower CCT LEDs, 3000K to 4000K in outdoor lighting applications? Is it cost, consumer preference, CRI, efficiency, technology, et cetera, et cetera?
I think I don't know all the factors, to be honest. I will tell you what my perception is of the reasons why we're not seeing more 3000K installations occurring. I think that there's a sort of maybe a habit or a preference for choosing 4000K products. There's 4000K products available from many manufacturers out there. It's really easy to find a lot of products that are there. We are seeing more and more 3000K products available. In fact, one of the efforts we undertook a couple years ago that we presented at the IES annual conference was a poster that showed that lower CCT products were becoming more and more prevalent over time on the DLC's QPL. So I don't know if it's perhaps lead time. You know, the most often sold products potentially are the ones that are available the most quickly, and in order to sort of change that equation, people have to pick these products more often. I will say that we have to have both supply and demand. As cities demand more lower CCT products from manufacturers, there will be more effort in developing these products. I mean, manufacturers, frankly, want to sell products, and if they're making a lot of products that people aren't buying, they're going to be less interested in offering those types of solutions, because everybody needs to look at cost and benefit. So if you are interested in reducing light pollution, ask manufacturers to give you more of these lower CCT products. We are seeing more and more products available at 2200K. Recently, 2700, 3000K. We have those types of products already listed on Luna, and I'm really excited about the future, especially when we look at even lower CCTs. There's a lot of innovation that's happening from LED chip manufacturers to develop LEDs that are low CCT, 2000K, 1800K, have high color rendition capability, and potentially high efficacy and good lumen maintenance and color maintenance. So the future is bright, excuse the pun, indeed, for even more choices in the future. But we have to use them. We have to demand them to really make a difference here.
And kind of related to that last question, are Luna products eligible for rebates?
Yes, absolutely. So every Luna product is DLC listed, is already SSL 5.1 qualified. We find that utilities across the United States and Canada, the vast majority of them require DLC listing. So if your utility offers a rebate for DLC qualified products, either as a prescriptive rebate or a custom rebate, those Luna products are eligible for those rebates. So take advantage of the win-win here of the rebate, energy efficiency, and light pollution mitigation. Great question.
All right. So there's a lot of good questions in here. Some of them are a little technical, so I'm not going to make Leora try to answer these live, but we'll be sure to get to everyone.
Yes.
But here's a good one about dimming. When using dimming on outdoor lighting, are you overlighting, then dimming to the requirements, or lighting to the requirements, then dimming from there?
The second, lighting to the requirements and then dimming from there. So in our case, when we were choosing the layouts, the products themselves, we were looking, in this particular scenario, we were looking at the lowest wattage products that were available from that manufacturer, you know, in that CCT and distribution, that could meet the light level requirements that we had. And then any post-curfew dimming that was applied and described in the white paper was done on top of those products. One of the things we did not do in this simulation scenario is apply, for example, additional high-end trim to exactly meet the maintained illuminance requirements. That could potentially get us even deeper energy savings and further light pollution reductions, but we did not take that additional step in this first study here.
Thank you. What are your thoughts about having a very comprehensive and precise lighting ordinance, like the one in Fort Collins, compared to a much simpler and easier to understand, but much less precise ordinance? In your experience, which one yields better results in the end?
That's a great question.
Yeah,
so
one
I'm
for
going to
discussion,
put my,
probably.
it's worth a discussion. I'm going to put my engineer hat on for a moment. So in my previous life, I had much more of an engineering focus. And as a lighting engineer, it's really easy to work off of a checklist. So if it says use these CCT products and not these, it's really easy to check that off. It's really easy, for example, to pick products that have, say, only a certain percentage of uplight, or aren't allowed a certain percentage of uplight, or do have bug rating requirements. So from a checklist perspective, it's a lot easier and simpler to comply with a lighting ordinance that is very prescriptive. I think simpler ordinances are potentially easier to implement, but in my experience, they're a lot harder to understand. And in both cases, whether they're simple or comprehensive, if they are not enforced in some way, that's when the real trouble happens, and we see a lot of unintended consequences. So enforcement is a key piece of this. And so in one way, prescriptive requirements might be easier to enforce because it's very easy to see prescriptively, did they meet these requirements that we set out, versus going into the field and making a bunch of measurements and trying to understand what it actually means to use simple words. So I think I'm on the side of more prescriptive is easier across the board.
Thank you. And yeah, so we've shared a lot of information here today. People are wondering if we'll post the webinar and if we'll be sharing your slides.
Yes, to both.
Great.
Those will come shortly. We will post them on the DLC website, and I'm sure we'll be sending that information out. So thank you.
Oh, and you can review this later, but we do have an invitation to join the Artificial Light at Night conference in Ireland this October. So thank you very much, Diane.
Next October.
Yeah. Oh, yeah. Next
2025.
October, 2025.
And I'm very excited to go to that conference. I think I went in 2023. Was one of the best conferences I've ever attended. I think where we're going to make big progress is when we have experts from various disciplines working together. So whether that's astronomers, physicists, ecologists, and biologists, we all bring our own expertise to the table, but we can't fix what we don't know, and we can't fix what we don't measure. And so together, I think we're going to get an answer that is much larger than the sum of its parts. That's what I hope we see in the future. And thank you.
Yeah, we got some pretty pointed questions coming in too. Did you add a depreciation factor when doing the photometrics for exterior lighting?
Yes, so we had two sets of calculations. The ordinance calculations, the light pollution requirements, require a light loss factor equal to 1. So initial, not maintained requirements. But when we were choosing products, we were designing to maintain illuminance requirements, and we used a total light loss factor of 0.7 when we were using LED.
And did your study look at the factors of reflected light? If
Yes,
not, what impacts do you think reflected light adds to the sky glow?
That is a really good question. So we did have, for example, in the model high school, we had surfaces for the ground, we had surfaces for the building. So yes, we had some aspects of reflected light in the model. It's really important in a photometric simulation that you model as much as you can and as accurately as you can, because if it's garbage in, it's garbage out. So yes, we also had to some extent that occurring in the street lighting simulations as well. I will say that the impacts of reflected light on sky glow in a granular basis are not there, not in the simple tool that we used. One of my fervent wishes for the future is that the photometric tools that we use on a day in and day out basis will actually start to look at atmospheric scattering, because then we can really build on the granularity that we have in tools like AGI 32 and be able to look at all of those impacts across the board. So maybe someday we'll be able to do that all in one tool, but we need the information. We need obviously the scientific information to feed into the models, and we also need demand from end users using these tools to make that happen.
All right, and so we're just about out of time.
Sure.
A little less than 2 minutes to the hour. So I think let's answer, generally what is Luna? People just sort of wondering what the distinction there is.
Sure. So Luna is a program that the DLC has where the outcome is a qualified products list that has energy efficient lighting that meets illumination requirements. So it has good color rendition, good color maintenance, good lumen maintenance of human built environment applications, and mitigates light pollution. And so we really think of it as an overall comprehensive program that not only builds on the energy efficiency aspects of LED lighting that have led to market transformation and support larger decarbonization goals, but also rolls into the program really important specific light pollution criteria at the same time. So Luna has detailed performance requirements that are published called our technical requirements. And in there we have requirements for CCT, requirements on distribution and on mounting structures so that you can't aim the products up to the sky, and requirements for controllability and controls reporting to support these larger goals. So I guess an easy button for energy efficiency and light pollution is how I think of Luna.
Thank you, Leora. So yeah, we're just about out of time. There are a lot of questions we didn't get to, but we have your emails, we have your names, we have your questions. We'll be sure to get to them.
Terrific. I look forward to further conversations. Thank you so much for joining us today. Sorry we only had an hour. I hope you have a great week, and I look forward to speaking with you soon. Bye, everybody. Thank you so much.